Okay, so we talked about this formula here, v equals d over t, or this formula, v equals d over t. How are they different? Right, one is for scalar quantities, like distance and speed, okay? And one is for vector quantities, like displacement and velocity. And boy, did that just go wrong right from the get-go. Velocity. Okay. Now, we talked about the manipulation a little bit on Monday, how we do that. Okay, if we want to get d by itself, okay, we multiply both sides by t. Because remember, the rules of algebra say if you're going to move something, you do the opposite. And what you do to one side, you do to the other side. It's as simple as that, guys. We had that little thing we added in after as well that move the things that aren't attached to what you're looking for first, but we're not going to need to remember that for a while yet, but it's in there. Okay, so if I want to get d by itself, I multiply both sides by t. T comes over here, and now I'm solving for d. Okay, if I want to solve for t, then I do exactly the same thing so that t is over here. Remember, we don't want to solve for it if it's on the bottom. Okay, and then I divide both sides by v. V comes over here, and now I'm solving for t. T equals d over v. All right, everybody follow me there? A little bit of practice, and trust me, this will be second nature to you. All right, it's not really difficult algebra. Okay, so I'm going to write an example up here, and I want you guys to try it out. Okay. We did about 5 examples the other day, so I'm going to assume we're about on example 6 or so. All right, so a little trick to this question, okay? Inspired this morning, though, because how many people know what happened this morning? Kind of a big deal, something that's never happened before. No, rocket didn't blow up, because that's happened before. Lots of times, unfortunately. Okay, the Rosetta probe landed on a comet this morning. Okay, they've been trying to get this probe to land on this comet that's been moving through our solar system, and it landed on it this morning successfully. Okay, and it will now begin running tests on what the comet is made out of and things like that. Okay, hopefully giving us some insight into how our solar system was formed, what was present or very early on, and things like that. So it's going to be kind of a big deal. They'll have some stuff on it. I think either Discovery or National Geographic has a show on it tonight at some point. So if you got nothing else to do, and I'm not assigning you any homework, you might want to watch that. Okay, so how far will a rocket traveling at 4,500 meters per second travel in 4.3 hours? Okay, my velocity, or sorry, my speed is in meters per second, and it's 4,500. Okay, but my time is in hours. Is that going to work for me? No, because the units for time in my speed are seconds. All right, so I need my units for time to also be in seconds. So, how many seconds in an hour? People want to say 60, so desperately they want to. Not 360, 3,600. All right, so we're going to say 4.3 times 3,600. All right, so we're looking at 15,480 seconds. All right, so I've got V and I've got T. I'm looking for D. All right, so V equals D over T. All right, I need to manipulate to get D by itself. So since I'm dividing by T, I'll multiply both sides by T. Okay, and now I'm set up to solve for that. So D is going to equal Okay, 15,480 seconds times 4,500 meters per second. All right. Pretty far. All right, so we're looking at 69,660,000 meters. Very far. Okay, if it was traveling at that speed. Okay, now 4,500 meters per second. Does that sound fast? Okay, on Earth that would be incredibly fast. Okay, but when you're talking about interstellar distances, that would still mean it would take a very long time for you to travel, even let's say between Earth and the Moon, okay, or Earth and Mars or wherever. All right, so while it seems very fast, okay, in terms of the distances that have to be covered, it isn't all that fast. So we had, was it 69,666,000 meters. Hey, is that ringing a bell? Okay. Note about parent-teacher interviews, which are tomorrow. If your parents have booked an interview with me, that's great. Okay, you should come. You should come with them. All right, they are actually supposed to be called student-centered conferences. It's a politically correct name for everything. Like sanitation technician is the politically correct name for garbage man. Okay, all right, but the idea is that you should come along. Because there's nothing I would say to your parents that I wouldn't say in front of your face. Okay, so you might as well come along, right? And it's good if you do, right? So I encourage you to do so. If they've booked an interview with me, come along. That way you can defend yourself. Not that I would say anything bad anyway. Okay, all right. So I'm gonna have you try some stuff off of this worksheet here. Okay, it's got the answers on it. All right, and that's the idea, so that you know whether you've done it right or not. Okay, so work through these, and then if there's any that give you trouble, we'll go through them as a class. All right. For right now, I just want you to do the first side because it is two-sided. Okay. The second side is all vector stuff, right, where there's positives and negatives, norths and souths. Okay. The front side doesn't have any of that. Right. So it's a little bit easier in that you don't have to keep track of that stuff yet. So we'll start out kind of slow and then work into it from there. Okay, guys, for question number 3, just to eliminate some confusion, it's 2 separate calculations. It wants you to calculate the speed on the way out and the speed on the way back. All right, the distance is the same. In both cases, it's 604 meters, but on the way out, it's only 2.19 seconds. On the way back, it takes longer. Okay, 2.2. So it's just 2 separate calculations for that one. All right. So on number 3, they're telling us the world record is 274 meters per second, but we're probably not going to use that, okay, in our calculations. It's the average of the 2 runs. So what we want to do is figure out the average velocity for each run. Well, average velocity, in this case, we're actually we're calculating average velocity because we're putting a direction on it. Okay, we know that one time it's to the right and one time it's to the left. Okay, so average velocity is displacement, or in this case distance, 604 meters. Okay, we're going to put a direction on that to make it displacement. 604 meters right. So this is a velocity for run 1, okay, when he goes out. 604 meters to the right, and that happened in 2.19 seconds, as the question said. Okay, so when we do that, 604 over 2.19, we get 276 meters per second to the right. On the way back, he's moving to the left. Same distance, okay, just this time it's to the left. 604 meters left. Okay, divided by the time. He was slower on the way back. Maybe the wind was against him or something. Okay, 2.22 seconds. All right, when we do that, we get 272 meters per second left. Okay, you average those two runs, and you get the world record of 274 meters per second. Okay, does that make sense, Evan? All right, any others? 4. Okay, so this is one of those 2-part ones where we have to find total distance and total time. Okay, so what we want to do is write down our givens for part 1 and for part 2. Okay, so in part 1, it goes 11 kilometers at a velocity of 21 meters per second. So since my velocity is in meters per second, what should my distance be in? Meters. Okay, well that's easy. There's 1,000 kilometers in a meter, so this is 11,000 meters. Okay, and then for part 2, the givens are distance again, this time 1,000 meters, 1 kilometer, okay, and a speed of 4.2 meters per second. All right, we need to find the average velocity of the bus for the entire trip. Well, average velocity is total distance. Sorry, it should say average speed there, not velocity. Total distance over total time. All right, well, I can do the total distance right now because I had distance for both parts. Okay, 11,000 plus 1,000 is 12,000 meters. Okay, but I don't have the time for either one. Is that okay? Can I find it? Yeah, I just have to do t equals d over v. Okay, my manipulation there for t for both of them. All right, so 11,000, all right, over 21. All right, gives us 523.8 seconds. Okay, plus whatever the time for part 2 is, and to do part 2, same idea, t equals 1,000, the distance, over the time, 4.2. All right, 238.1 seconds. All right, so now I can punch that into my calculator, go 12,000. Okay, the trick here is that you have to do the bottom operation first. Okay, you have to have the total time. Otherwise, if you just go 12,000 divided by without brackets 523.8, it'll do that first, and then it'll add 238 to that number. Okay, so 523.8 plus 238.1. Right, and we get 15.8 meters per second north. Okay, total distance over total time for any multi-part trip is what we got to do. Okay, so any trip that has more than one part, you'll do this. No matter how many parts it has, you'll write down the givens for each part, solve for anything you don't have. You need the distance for each part and the time for each part. If you don't have them, find them, and then you do the totals at the end. Okay, everybody with me there? Okay. Any other ones? All right, keep going. I don't remember what number it is here. Okay, it's for the, well, it's been broken since, it's about 3 minutes 21 seconds now. Okay, this is 3 minutes 29.46 seconds. All right, that's what that's saying there. 3 minutes 29.46 seconds. Okay. All right, so number 12 is one of those multi-part questions, but it's slightly different in that this multi-part question actually gives you the total distance and the average velocity. So again, what we want to do is write down everything we know. Okay, all the parts and the total. All right, so in part 1, it goes 25 kilometers per hour for 15 kilometers. Okay, so v is 25 kilometers per hour. D is 15 kilometers. Okay. In part 2, we've got 62 kilometers per hour and 32 kilometers. Okay, in part 3, all we know is 13 kilometers for part 3. And they tell us some totals. They tell us the average velocity is 40 kilometers per hour. And the total distance is 60 kilometers. Okay, they want me to find out the velocity in this part. What do I need in order to get that? What am I missing? Right, I'm missing the time for part 3. All right, so I got to find a way to find the time for part 3. Okay, so now I'm going to look at what I've got so far and see what I can get from that. I can find the time for part 1, for part 2, and for the total. Agreed? Okay, so in general, if you're in a multi-part question and you're trying to figure out where to go, find everything you can. Write down your givens and then calculate everything you can, and sometimes the answer will pop out at you. All right, so what I'm going to do right now is calculate the time for all of these. So time equals d over v. That's going to be 15 over 25, and that's what, 0.6? Okay, and then for part 2, same thing. T equals d over v, 32 over 62. All right, and that's going to give me 0.51. Okay, and these are all in hours. I should put units on those. Can't do anything else with part 3, but I can find the time for the whole trip. All right, so that's going to be 60 over 40, which is 1.5 hours. Okay, the whole trip takes 1.5 hours. And I know how long the first 2 of the 3 parts take. So can I find the time for the last part? Yeah, I'll add the first 2 parts together and subtract it from the total. What's left must be how long part 3 took. Okay, so I've got 1.11 hours, okay, as my total between part 1 and part 2, right? 0.6 and 0.51 is 1.11 hours. Okay, so I subtract that from 1.5. Okay, and that should leave me with 0.39 hours, is that right? Okay. All right, so there's my time for part 3. Can I find V now? Yeah, because now I have D and T. All right, so V equals D over T, 13 over 0.39. Okay, and that should give us 34.2 kilometers per hour. All right, so basically it's just I wanted you to have to do a bunch of calculations before you got the answer. Okay, yes, that's cruel and unusual punishment, but okay. Does everyone follow me on how that one worked? Any other ones? I did. 34.2 kilometers per hour. It says velocity, but it should just be speed. I mean, I forgot to take the north off of the answer here. I mean, if this was supposed to be all speed, then there shouldn't have been any directions on there. 11? Okay, so 11 is just another one of these 2-part questions, right? If I want to find average velocity, I need the total distance and the total what? Time. All right, so in part 1, person falls 625 meters in 15 seconds. And in part 2, they fall 356 meters in 142 seconds. All right. If I need total distance and total time, can I get that with this information? Yeah, sure I can. Okay, I just have to add these 2 together here. So we'll be looking at 981. So 981 meters, okay, divided by 157 seconds. Okay, and that should give you my 6.25 meters per second down. Total distance over total time. Anytime you got a 2-part question, okay, you're probably going to be having to do that, okay, including this one, right? They just, in this case, they gave it to us. They gave us the total distance and the average velocity, but I still used it to calculate the time. We're always going to use that in a question with more than one part. All right, any other ones? Rachel? 9? Is that this one? Okay, sorry if the numbers didn't come through for some reason. Okay, so in this one here, I'm comparing the old guy and the young guy. Okay, so the young guy can run 10,000 meters, because I have to turn it into meters. My speed was given in meters per second. Okay, he can run the 10 kilometers at 4.38 meters per second. The old guy runs the same distance. Good for him. Okay, 10,000 meters, but he does it slower because he's old. Okay, 4.27 meters per second. And if I can still run 4.27 meters per second when I'm 50 years old, I'm pretty happy with myself. Okay, now, if I want to find out how much of a head start or how much later the younger runner should start, what do I need to know about both of these people? Right, I need to know the difference in their times. First thing I need to know is how long does it take each of them to run 10,000 meters? So T equals D over V. 10,000, okay, over 4.27. All right, so it takes the old guy 2,341.9 seconds. All right, and the young guy, same calculation, 10,000 divided by his speed, 4.38. All right, takes him 2,283.1 seconds. All right. So if I subtract those two times, will that tell me how much later the young guy should start? Yeah, and then they'll finish at the same time. All right, so if I take my 2341.9 and subtract 2,283.1, okay, I should get 59 seconds, right? No, as long as you did that method, you should be okay. Any others? Okay, on the second side, okay, now direction starts to matter on the second side. All right, so we'll go over number one here from the second side together just so you get the idea. Okay, remember that now we're dealing with velocity being displacement over time. And remember that displacement is how far and in what direction you end up from your starting position. So if you go ahead and then backtrack, okay, it doesn't matter that you've maybe gone 5 kilometers in doing so if you only end up 1 kilometer from where you started. So on this one here, we have a person who goes up 260 meters. And then they descend 150 meters. All right, so that space right there represents their displacement because it's how far from where they started they finished. Okay, how am I going to find out how much that is? Subtract the two, right? 260 minus 150, okay? And that's going to give me 110 meters, right? Okay, so my total displacement is 110 meters, okay, divided by the total time, which they told me, got cut off here, 240 seconds. Okay, and then I should get, for her velocity, 0.458. Now, for part A, which I skipped because it was cut off, okay, for part A, it asked me what's her average speed. Now, does speed care whether I went up and down? No, because it only cares how far I went and how long that took. So she went 260 plus 150 this time, okay, giving me 310 meters, right? No, 410 meters. Did I do that right in my head? Somehow that doesn't feel right to me. 260 plus 410? Okay, well, I'm not going crazy. All right. So if I want to find speed, speed is distance over time. Okay, scalar, 410 meters divided by 240 seconds. That doesn't change. That's why we get 1.71 meters per second for that part. Okay, so it's the first few are going to ask you, make sure you're understanding the difference between vector quantities and scalar quantities. All right? So if you're done the first side, you can start on the second side here with the vector ones. Really, mathematically, they're not a whole lot different. This would be about the only thing that would be new. Okay? And that's just keeping in mind that if you go forwards and then backwards, you have to subtract the two. Okay? All right, keep it going there, guys.